Okay, so let's sketch some graphs. So we're gonna sketching sine waves and cosine waves. You know how to, you can, we know from the intro to transformation, I actually asked you to, look at a sine bx minus c plus d. I asked you to investigate this. So we kind of know what the sine wave looks like. Let's take it from another perspective. So we also know that uh, C and D are the shifts, and we know that A and B are the stretches. So we kind of know what's going on here, but let's just kind of let a closer look. So, for example, first of all, y equals sine of theta. We know because of the unit circle, it's like the height. So we know it starts at 0, up, down, up. This is the basic sine wave. Basic sine wave. And if we look at cosine of theta, we know that it was the distance from the y-axis. We know it started at 1, 0. So it's like 1, 0, negative 1, 0, 1. So we start here, kind of looks like this. And we call this the basic cosine wave. And so, and we can make a quick chart. So for example, y equals sine. Let's take a look at y equals sine theta. And so we know like 0, 90, 180, 270, 360. We know that sine of theta is 0, 1, 0, negative 1, 0. So what I want to do is I want to explore, first I want to look at what happens when we change the A. So what happens if I do, 2 sine theta? Well, we know it's a vertical stretch. Well, what effect does that have? Well, we know, sine of 0 is 0, times 2 is 0. Sine of 90 is 1, times 2 is 2. Sine of 180 is 0, times 2 is 0. Sine of 270 is negative 1, times 2 is negative 2. And sine of 360 is 0, and that brings us back to 0. Or how about if I do negative sine of theta? You're like, okay, we can figure that out. Sine of 0 is 0 times 0, negative 5 is still 0. Sine of 90 is 1 times negative 5 is negative 5. Sine of 180 is 0 times anything is 0. Let's see, the sine of 270 is negative 1 times negative 5 is 5. And the sine of 360 is 0 times anything is still 0. And then you might say, well, the numbers are different. What we're concerned about, what I want to just bring a point is that each of these has a max and a min. And I don't care whether there's a negative or a positive. It doesn't matter. It seems that the map A, which we're going to call the amplitude, A is known as the amplitude, and A is the amplitude, and it turns out that A is the max, and negative A is the minimum. Now, it doesn't matter whether we just know this negative is a reflection, it's just going to flip it around. But the idea is that when we have, A sine of x, our maximum is always A, and our minimum is always negative A. I want you to look up these graphs in Desmos. Okay, now I'm sorry, and then the last thing I'm going to talk about is that A is actually equal to the distance, the absolute distance between the max and the min divided by 2. No, we put the absolute because we're not interested in the negative. That does not concern us. The negative is just the reflection. And I guess I could write here, y of negative sine of theta is simply this. And y of negative cosine of theta is simply this. So the negative is for this. The amplitude deals with the distance between the maximum and the minimum. Okay, so let's move on. Now, let's add a shift. Let's add the vertical shift. So, for example, we're interested in what's going on with y equals, a sine theta plus d. How does that affect it? Well, let's take an example. Let's just use an example. Y equals 2 sine theta plus 5, right? Okay. Well, let's get our chart down. So we have 0, 90, 180, 270, 360. Let's build up. Well, I know that sine is 0, 1, 0, negative 1, 0. I know that 2 sine of theta is 0, 2, 0, negative 2, 0. And then we add the 5 on. 2 sine theta plus 5 is 0. I'm sorry. Basically, we're adding 5. So it's 5, 7, 5, 3, 5. So let's say, good. So what we notice here is that, once again, it changes the maximum and the min. So the max is actually, this is the proper max. The max is actually the A, right, plus the D. And the minimum is actually negative A, still plus the D. It's still shifted up. Now, does it affect the amplitude? Well, does a vertical shift affect the amplitude? And the answer is no, because the amplitude is kind of like the stretch, and we're just shifting the whole thing up and down. We can see that with the formula here. I mean, we could take some examples here. 7 minus, for example, 7 minus 3 divided by 2 is 2. So it doesn't change it at all. No. So remember this. Nice. The last thing I want to look at is y. Let me just erase this. Next thing I want to look at is the b. Let's see how that affects my graph. Well, my first thing is, does the b affect the amplitude? So sine of b theta. This b is it gonna? What kind of effect does it have on my graph? Well, we know from transformations that's a horizontal stretch. So it does not affect the amplitude. So b has no effect on the amplitude. So it doesn't change the max and it doesn't change the min. It has nothing to do with the max and the min. It's just it's stretching the sine wave. And you can see that in Desmos, how it stretches the sine wave. Let's see. So B is actually the number of cycles over 2 pi. So we know. So let's take a look at cosine. This is going to be sine. Let's sine and cosine. Let's take a look at cosine of theta. So 0, 90, 180, 270, 360, and I have cosine of theta. Well, cosine of 0 is 1, cosine of 90 is 0, cosine of 180 is negative 1, cosine of 270 is 0, cosine of 360 is 1. I've memorized these. Get these in your head. I mean, you should know these basics. And so the question is, how does it affect? So looking at the graph, we know this is our basic sine wave. We have one wave over 2 pi. That's what the b is. And I'm just going to call it b. Let's see what happens when we do cosine of 2 theta. But this time, what I'm going to do is I'm going to change my column. So I'm going to use 0, 45, 90, 135, 180. And I'm going to do 215. 270. No, 225, I apologize. 270, 315, 360. Let's see what's going on here. So, once again, we're looking from 0 to 2 pi, 0 to 360. Once again, I'll say it again and again and again, sorry. Speak the language of radians, like know that language. So, we're looking from 0 to 2 pi. 2 times 0 is 0, 1. 2 times 45 is 90, the cosine of 90 is 0. 2 times 90 is 180, the cosine of 80 is negative 1. 2 times 135 is 270, the cosine of 270 is 0. 2 times 180 is 360, the cosine of 360 is back to 1. Cosine of 225 is 450, which is that's like 90, so we're back to 0, right? Because 450 minus 360 is 90, so it's the same place. 270 times 2 is 540, which is, so 540 minus 360 is 180. Well, the cosine of 180 is negative 1. 315 times 2 is 630. 630 minus 360 is like 270. And that's 0. And 360 times 2 is 720. And then it takes us back to 1. So what's going on over here? From 0 to 360, we have 1 wave, 2 waves. So we see here that the 2, we have 2 cycles over 2 pi, hence the 2. That's the idea of the B. So the second you see the 2 there, you're like, okay, it's happening twice. The last example I want to show you is what's going on with how about we do like cosine of half theta? Cosine 1/2 theta, right? Because we're higher level math, we can explore that. Well, let's see what's going on. Let's do 0, 90, 180, 270, 360, 450, 540, 630, and 720. Please remember, we want to know what's happening from 0 to 2 pi. What part of the wave is occurring from 0 to 2 pi? Well, let's make our table. Fine. What's a half of 0? 0. Cosine of 0? 1. What's half of 90? 45. The cosine of 45? Radical 2 over 2. You have to know that. All advanced math students know that. What's half of 180? 90. The cosine of 90? 0. 270 divided by 2 is 135. What's the cosine of 135? Well, 135 has a reference angle of 45. We know that cosine of 45 is radical 2 over 2, but cosine is negative in a second. 360 divided by 2 is 180. The cosine of 180 is negative 1. 450 divided by 2 is 225. 225 has a reference angle of 45 degrees. Once again, we know that the 225 is 45 degrees away from the x-axis. The cosine of 45 is radical 2 over 2, but we know that cosine is negative in the third. 540 divided by 2 is 270. The cosine of 270 is 0. 630 divided by 2 is 315. 315 has a reference angle of 45 degrees. The cosine of 45 is radical 2 over 2, and because cosine is positive in the fourth, we know that the cosine of 315 is radical 2 over 2. And you know from patterns, at some point you kind of know what this looks like. What's going on with 720? 720 divided by 2 is 360. The cosine of 360 is 1. So what's going on here? So look at the graph. We have 90. Let's see what's happening. Let's go to 360. We have 180, 360, 540, and 720. And we look at the graph and we see, okay, so we know So by 360, we only have half the graph completed, and hence that's what the half is. That we only have half of it done. You can continue if you want. And that's the other half. So we get a full cycle over 720. So what's that number? So let's move on. Because you might say, Ms. Rather, we get a full cycle over 720. What does that represent? That's the period. The period is 2 pi over the absolute value of b, and this is the interval over which one complete cycle occurs. So we see here, we see here that 2 pi divided by the 1/2, it's never going to be negative. Like, that's just, we have no purpose for that in this class. This is 4 pi, hence the 4 pi. This is 2 pi, 3 pi. That's 4 pi. So we get a full cycle from 0 to 4 pi. How does that apply here? I'm going to use the green marker. Let's see, what's the period? The period is 2 pi over 2, which is pi. Okay, that makes sense because we got a full cycle here from 0 to 180, or pi. And when the cosine this is 1, we got a full cycle from 0 to 2 pi. Now, let's get to the good stuff. So that's, okay. Sketch y equals 5 sine 2x plus 6. Now, you can you can use your technology for this, but I want to teach you a quick way to get a sketch down that you can quickly validate on your technology. First of all, what does this look like? You go, it's a sine wave. Is there a reflection? Is there a negative number? No? Fine. No reflection. Next, what is the amplitude? The amplitude is 5. What's the V shift? The V shift is 6. Therefore, what's the minimum? You go, okay, fine, it's negative 5 plus 6, or 1. What's the maximum? 5 plus 6, or 11. Now, it's kind of interesting. You might say, hey, Mr. Rather, what right between 1 and 11 is the 6. Actually, this is also known as the midline. This is the midline. Sorry. midline. It's kind of like the middle. Because we know that something goes up, down, up. But that line in the center is the midline. The B is 2. Therefore, the period is 2 pi over 2, or pi, or 180. Something we didn't talk about. Something we did not talk about is the horizontal shift. We'll get to that in a second. That's a little advanced, and you'll use your technology for that. And there's no horizontal shift. So we're good to go. Draw your regular axis. We have a sine wave with no reflection. Draw a sine wave in. This is your max. This is your min. This is the midline. The period is pi. So this is your pi. This is your pi over 2. This is your pi over 4. And this is your 3 pi over 4. And you have just sketched the graph of 5 sine 2x plus x. Done. Let's try another one. Y equals negative 2 cosine 1/3. You can do this. Did I put an x in there? I really should have put in a theta. Theta minus 5. Okay, no big deal. We can figure this out. Well, let's see. I know it's a cosine wave, and I know there's a reflection. Okay, so I know the amplitude is 2, and I know the v shift is negative 5. Therefore, the minimum is negative 2 minus 5, which is negative 7, and the maximum is 2 minus 5, which is negative 3. The midline is 5. What else do I know? I know that b is equal to 1/3. So the period is 2 pi over 3 over 1/3, or 6 pi. And there's no horizontal shift. So let's get a sketch down. We have technology for perfect graphs. We just want to get a nice sketch down. So you're like, okay, we're going to start at 0 and go to, well, let's just do, first of all, I have a cosine wave and it's a reflection. So I know it looks like this. I know it starts at 0 and ends at 6 pi. I know the max is negative 3. The minimum is negative 7. And the midline is negative 5. And let me break this up. So half of 3, this is 3 pi. This is 3 pi over 2. 4.5 pi if you want. That's the idea, that you kind of know where it is. And there, once again, you drawn another one. In physics, so you have to answer physics. This is not, so we talked about the period. You might see a word frequency. You might see a word frequency. This is a physicist, right? I have a video for this. I worked with Mr. Appleby. Frequency in math is a little bit differently than what the physicists want. Now, I used to think that B was the frequency. It's not really, because in math, we're interested in how many times a wave occurs over 2 pi. So I might say the frequency over 2 pi is 2. Or the frequency over 2 pi is 1/3. But the problem is, in physics, you don't care about 2 pi. You care about like 1 second. You want to know what part of the wave occurred in 1 second. So the frequency in physics, and you're not going to be asked in the math, and you're never going to see in the textbook, the frequency is actually 1 over the period. Now, this is more of a physics thing. So I asked Mr. Appleby, hey, Mr. Appleby was talking about this, and he made a mistake, and you were talking about this. So this is more a physics word, but we don't talk about it here because, yeah, it gets weird. Anyway, so let's move on to another example. Let's look at the phase shift, actually. So in math, we call it a horizontal shift, but in physics, we call it a phase shift. So when you see y equals 3, cosine of 2x plus 1 plus 5, we know the transformations that are happening. we know the first thing that we're doing is moving 1 to the left, and then we're doing a stretch by 2. But what we do in physics is, the first thing is, so we know, so in math, we know that this is x, 1 to the left, and then a vertical stretch, horizontal stretch by a factor of 1/2. Okay, but physics doesn't talk about this mathematically. What physics does is they rewrite this. They write 3 times cosine of 2 plus 1/2 plus 5. And then so we move 1 to the left, and then they shrink it by 1/2. We do that with that. The physicist just pulls the 2 out to get the 1/2. So we know, yeah. So this is the phase. So we know that it's a horizontal shift of 1/2. This is known as the phase. Therefore, the phase shift is 1/2. Phase shift is 1/2 to the left. And so what you would do is, what I would do, or I recommend the students do, is, so for example, when they graph, let's say this one. So you know that it's cosine, no reflection. What's going on here? Well, we know the amplitude is 3, and the V shift is 5. So we know the minimum is a -3 plus 5 or 2, and the maximum is +3 plus 5 or 8. We know the period. The B is 2, right? And therefore the period is 2 pi over absolute value of 2, or pi. And the first thing I recommend kids doing is, if you need to sketch it, you're going to be getting technology with any of these questions, because these end up being like elaborate word problems. So you have the technology. But if you have to sketch it because someone insists that you say, fine, I'm going to sketch my my cosine function without. So you say, fine, it's a cosine wave without a reflection. Maybe extend this out a little bit. I know the maximum is 8. The minimum is 2. The midline is 5. What do we have here? We know that the period is pi. Okay. Which is, we're going to use like 3.14, right? And then we can fill this in if we have to. Pi over 2, pi over 4, 3 pi over 4. And then the last thing is, how do we acknowledge the horizontal shift? Well, we know that it's half to the left. Literally, you're moving everything like 0.5 to the left. Everything gets shifted. So hey Siri, 3.14 divided by 4.
3.14 divided by 4 is 0.785.
So this is getting shifted over half, a half. It's actually not the full. So this is getting shifted over half. This is a half, and this is a half. And so the shift And so this is a phase shift of a half. So the green is, this is the green. That's the idea of the phase shift. Once again, you're going to have technology for this. Let's take a look at a word problem. So let me stop the video. Let me pause it. Okay. A Ferris wheel whose center is 51 meters above the ground has a radius of 50 meters and completes a full rotation every 60 seconds. Write an equation representing the height of someone who goes on the Ferris wheel. And the next question is how high is someone after 17 seconds and 42 seconds. So I said there's a Ferris wheel. Let's see, a Ferris wheel whose center is 51 meters above ground. Has a radius of 50 meters and completes a cycle in 60 seconds. So the first thing you're going to do is the second you see anything that increases, decreases, over time, you might see the tidal waves or something like that. First of all, I'd make a chart. So I know that it starts at, so let's see, what does the picture look like? So we have a Ferris wheel, and the center is 51 meters above the ground, but the radius is just 50. So this is 50, this is 1, 50, 50. So when you get on at 0 seconds, you're at 1. And then, maybe 30 seconds later, you're at 101. And then, after 60, you're back to 1. And then what happens at t equals 15 or in t equals 45, you're at 51, 51. That's how to make a chart, and then you kind of look at your graph, and you're like, maybe you have 1, 51, 101. You say, oh, you know what? That's a cosine wave with a reflection. And so the question is, we know it's like y equals a cosine bx plus d. So the question is, how do I figure out my a, my b, and my d? Well, we have a couple. Let's start with the max and the min. We know that the minimum is 1, and we know that the maximum is 101, and we know that was the amplitude plus the shift. I'm sorry, that was the negative amplitude plus the shift, and the maximum is equal to the amplitude plus the shift. And these are just simultaneous equations. So let's add these together. So we have 102 equals 2d, d equals 51. D equals 51, right? And then we can take the second equation because that's easy. Let's see, a plus 51 plus 10 equals 101, a equals 50. And then the last thing we need to figure out is what this b is. Well, we know the period is 60, which is equal to 2 pi over b. So b is equal to pi over 30. Final answer, I'll do it in green because no one can see. Y equals negative 50 cosine pi over 30 theta, or you know what, we'll use t plus 51. And that is how we figure out. So you're going to see a bunch of problems. I'm going to ask you to sketch, and then you're going to look at word problems in the book. You're going to immediately look for how long does it take for a full cycle to complete. Maximum, generally max to max, or twice max to min. And then you're going to come up with the equation. Good luck.